Hello everyone, my name is Jasnoor and today I'm going to show you my project, a smart home monitoring and control system. The aim of this project is to design a small embedded system that can monitor different environment conditions inside a home and control home appliances like a fan, light and buzzer automatically and through user commands using a chat box interference. Let's start with the hardware component I used in this project. The Raspberry Pi 4 32-bit. It works as a main controller and web server. Arduino Nano 33 IoT used to read all sensors data and control the relays. DST22 sensor measure temperature and humidity. MQ2 gas sensor detects smoke and gas level. LDR sensor measure light intensity and the water level sensor detects water presence or leakage. PR motion sensor detect human motion and magnetic door switch detects whether the door is opened or closed. A 4 channel relay module control output devices like LED fan or buzzer in a normal home. Now let's talk about connections. Each sensor VCC is connected to the 5-volt pin of the Arduino. All sensors grounds are connected to the ground. DST22 digital pin is connected to digital pin 2. PR sensor is connected to pin 3. Door sensor is connected to pin 4 and relay IN1 is connected to DH5 and relay IN2 is connected to D6 for fan. Relay IN3 is connected to D7 for buzzer and MQ2 is connected to A0 pin and LDR is connected to A1 pin and the water sensor is connected to A2. The relay module VC is connected to ground is connected to 5-volt and ground is connected to ground and each relay's common is connected to 5-volt. The normally open pin goes to the positive side of each device, LED fan and buzzer, while their negative sides are connected to ground. The Arduino is then connected to the Raspberry Pi using a USB cable that allows serial communication between both devices. Now in my code there are 3 main code files. In the first is blink.ini. It's for the Arduino code. This code runs on the Arduino Nano. It reads data from all sensors every 2 seconds. It creates a JSON string containing temperature, humidity, gas, light, water, PR, and door values and send it to the Raspberry Pi through the serial port. It also listens for commands from the Pi such as light on or buzzer off, like these commands, and switch the corresponding relay. When the command is executed, it sends back an acknowledgement message like AC key light on. So Arduino is mainly handling the hardware level operations. In the second code is Python code, that server.py. It's for the Raspberry Pi Python code. This is the backend server of the system. It uses 2 main libraries like the Flask and Socket.io to run a real-time web server. It connects to Arduino through serial communication at dev/tt-acmo. It reads all the JSON sensor data and store it in the SQL-led dashboard database called sensor.db. It sends these values live to the web database. It also receives user chat box message and decides what to do. For example, if the users type a command like turn on LED, it sends relay turn light on and to the Arduino. If the user says some other commands like what is the temperature, it replies using the latest stored sensors reading. The code runs continuously and also automatically reconnect it if Arduino is disconnected. The third code is index.html. This is the front end web dashboard. It is the user interface display in the browser. It shows real-time sensor readings like temperature, humidity, smoke, and so on. It has a device status box showing whether the fan, light, or buzzer is on or off. It also has a chat box where the user can type commands such as turn on fan, turn off light, what is the current humidity, what is the water level, like these commands. and the dashboard updates automatically whenever new data is received. Now let's see how I run the system. Firstly, I open the Arduino IDE in the Raspberry Pi. I already selected the board Arduino Nano 33 IoT and the correct board, and then I click the upload option to upload the Arduino code. It takes some time. Once the code is uploaded, I'll open the serial monitor and I can see the live sensor readings like printing in JSON format. After confirming that the Arduino is working, I close the serial monitor because this step is very important. Only one program can use the serial port at a time. If we open the serial monitor as well as on the Arduino Nano, it shows some error. So I'll close the serial monitor, and then in the Raspberry Pi terminal, I go to my project folder with the command cd project, and then I go to the smart home where I have written my server.py file. So firstly, there are some commands that are not running in the Flask and libraries that are not installing in my environment. So I activate my virtual environment for some libraries so I can install them. So for that I use a command source venv/bin/activate, and after that I start the Python server with the command python3 server.py. When I run the command, I can see in the terminal a message come like the connected to Arduino on the port, and then the lines showing the sensors reading of different sensors. As you can see, the readings can vary if I change change the environment, like the temperature level increasing or decreasing, the water level, as well as the status of the door is open or closed. So we can see all these sensors data on the terminal. Now I open the browser in Raspberry Pi and type my IP address with port 5000. The smart home dashboard appears and showing all the live data. The data from the different sensors like the DHT22 PR sensor, dot sensor. So all these data I can clearly see it on the dashboard, and I can also verify it by test the system using different commands. Like firstly, I type the commands like turn on light, the LED turns on. When I ask for the turn on buzzer, the buzzer turn on. When I turn off the LED and buzzer, it automatically turn on. When I type some commands like what is the temperature, or there are different commands I can run, like what is the humidity, what is the door status, what is the water level. So all I can see in the chat box. So in summary, this project combines hardware, sensor, embedded control, and web communication. It demonstrates how an embedded system can monitor the home environment and also respond to real-time commands using a chat box and chat-based interference. If I had more time, I would add features like sending emails or mobile alerts when GANSO motion is detected, and maybe add voice control in the future. Thank you so much for watching.